to learn about Oneway Anova and the use of post-hoc Tukey test in Anova. With the help of post-hoc analysis, we can know which pair has significant difference. Anova helps to know the is there any significant difference between dependent and independent variable. But post-hoc analysis helps after finding there is a significant difference between variables, which pair has significant difference. Let us see some example. For Anova, we need two variables. One is dependent, another one is independent variable. If we take cholesterol level is dependent variable, various diet food affect the cholesterol level. So it is independent variable. Like average mile also differ based on brand. Problems of the retailer also differ based on age or experience. Parametric test, our data should be normally distributed. Usually we can check normality for scale data, we can't check normality for ordinal data. But in social science research, most of the time we are using Likert scale data for data collection. So we can take ordinal data as dependent variables sometime with some condition. If we have two groups, at the time we have to apply independent sample t-test. For example, gender, we have two groups. If our group have more than two, at the time we have to apply one-way Anova instead of independent sample t-test. Then we are using scale data for one-way Anova, we have to specify this assumption. Here I have used two types of data. One is scale data, another one is ordinal data for explanation purpose. Here scale data is sales per day. Independent variable is age. It is grouped into three. Let us see how to frame null hypothesis. My first variable is sales per day. Independent variable is age group. So you can frame null hypothesis either this method or this method. Let us see another hypothesis for another variable. Here my dependent variable is problems faced by retailer. My independent variable is different age group. So we can frame null hypothesis by following any one method. Spss file. Here I have used one scale data and 7 Likert scale data, that is ordinal data. This is my independent variable age. Let us see these variable in variable view. So age is grouped into three category and it is measured in nominal scale. Sales per day is measured in scale and the remaining problem 1 to problem 7 measured in ordinal scale. So he has specified the problems in label column. Let us know how to do one-way Anova. For that, click Analyze, choose one-way Anova from Compare Main. I have taken sales as my first dependent variable. My independent variable is age. So age move to factor. Test. So first click Tukey, give continue and OK. If our significant value lies between 0 and 0.01, our hypothesis is rejected at 1% level of significance. Look at this table, we got less than 0.001. Hence, our hypothesis rejected at 1% level of significance. That means it's a significant difference between sales per day and a different age group. Let us see Tukey test. So this is the mean value. By using this table, we can easily understand up to 30 years the average sales per day is 7,000. 30 to 45 years average sales is 10,455. But the above 45 years per day sales is 14,392. It is average sales. So each group has some difference. Let us see how to do one-way ANOVA by using ordinal scale data. For that, click Analyze. Choose one-way ANOVA from Compare Mean. Instead of sales, I am going to move Likert scale data, that is 7 problems, to the dependent list. Give OK. This ANOVA table, for first problem, poor risk taking ability, we got less than 0.001. So null hypothesis rejected at 1% level of significance. But for second variable we got 0.205. This value is more than 0.05. Hence null hypothesis is accepted. That means for first variable there is a significant difference among the age group, but the second variable there is no significant difference. Group have the same problem. Like that, third variable also have significant difference, fourth one also have significant difference, but fifth one there is no holiday. So this point is there is no difference of opinion among the age group. We can use post-hoc Tukey test only for the variable which has significant difference. So these two, second variable and no holidays, these are the variable don't have any significant difference. So we have to use post-hoc test only which has significant difference. So by using this table we can easily understand which group has significant difference. We need not to take the second variable for presentation purpose. Let us see. For first variable, poor risk taking ability, it is grouped into two. There is a significant difference among two groups, that is above 45 years and below 45 years. So among these two groups there is no significant difference. So above 45 years and below 45 years only have difference. The second variable already we don't have any significant difference, that's why it is not grouped. For third variable we got significant difference, but health problem is differ among all the groups. So like this way we can understand the use of Tukey test. Specify table for one-way ANOVA like this. You have to write interpretation. You have to specify the post-hoc Tukey test only for the variable which has significant difference. If the hypothesis is accepted, we should not take that variable for this analysis. For post-hoc Tukey test also you have to specify some interpretation. I hope you understand this video. Thank you.